In this video tutorial, we're going to go over a goal programming example as has been requested by a handful of people. In this, I'm going to just take an example from the supplement that was posted, and we're going to first extract information from it, formulate it as a goal program, then take that goal program, formulate it as a linear programming formulation, and then taking the linear programming formulation, put it into Excel, assign the appropriate penalty weights, and solve it accordingly using Excel Solver. So the first thing here is a write-up from the supplement. This is on the second page of the supplement. I'm not going to read through it. Essentially, they have three goals. They want to decide what products they should put money into, and they have three different goals: a profit goal here, an employment goal, and an investment goal. So all I've done is taken these three goals and put it over into our problem, into a text editor here. When you read through it, you realize they don't have any constraints on these particular variables. They only care about the goals. And so with that, I'm going to take these goals and formulate it first as a goal program. So I'm going to take these, goal programming formulation. All that the goal programming formulation is, I have my goals here, and then if I had constraints, I would have a set of constraints. For me, the only constraints here is that x1, x2, and x3 have to be greater or equal to 0. If I had some other constraint on them, I could say, something, 2x1 or whatever your constraint actually is, it would be in this section. So a goal programming formulation has my set of goals here with their appropriate, do I want to be greater or equal to, equal, or less than or equal to them, and then my constraints. Then I need to formulate this as a linear programming formulation. So the reason that we formulate as a linear programming formulation is I don't know which of these goals I can meet. There could be things that's preventing me from meeting all three of them. Here I have a greater or equal to and a less than or equal to. So maybe I can't satisfy both of those, but I want to capture how much can I satisfy. Would I be happy with meeting this at 126? Or 124, and then the others are met exactly. So I want to capture essentially how much I deviate. So it's going to be a minimization problem. We'll get to the objective function later, but first we're going to take these constraints. So we're going to take the goals here and put them as constraints because I don't know if I can meet them. If I kept it just here as these three goals, and if I can't meet all three goals and I solved it, it then would say it's infeasible. I can't meet all three, so therefore I'm done. And that doesn't give me any information of where I should be putting my money or what products essentially I should be investing in. So with that, I know that this possibly could evaluate to 126. And I want this to be an equality constraint. So I'm going to capture here the amount I deviate above the goal. We're going to put this as a superscript first, just for ease, so I don't think I'm adding or subtracting. So, but if this evaluates to 126, that would mean I deviate up one above the goal. I want this to be inequality. So therefore, I'm going to subtract off the amount I deviate above. So here would be like 126 minus I deviated one above minus 1 equals 125. And I want to do the same thing for the amount I deviate below. So here would be a D1 minus. So this is the amount I deviate below on goal 1. So if I deviated 1 below, that would mean this is 124. Then I want to add 1 unit to make this equal to 125. So that's all that these values are saying. I can't have one number that can be both positive and negative because I want all of my variables to be greater or equal to 0. So therefore I split it into the amount I deviate above and the amount I deviate below. That also helps with knowing, taking these signs. So if I'm greater or equal to 125, I want to know how much above and how much below I am this goal. So I'm going to do that for all 3 of my goals, but there's going to be different level of deviation. And it's splitting. So let's see if we can get this out here. Okay, so we're going to minus D2 plus D2 minus. We're going to say that this here equals 40. Something weird's happened with my tabs. I'm then going to do the same thing here. Minus D3 plus D3 minus strictly equals 55. And so therefore I've taken my goals and made them as constraints. And now here I can have them as constraints and capture how much I deviate from them. And I know I can get a feasible solution. If I had other constraints here above the greater than or equal to, I would carry those over, but right now I just have the greater than or equal to. So I'm going to keep that, but I'm also going to add that my D1 plus D1 minus, and then D2 plus D2 minus, all of those are going to be greater than or equal to 0. So these are going to be 2, and then I want for 3. So I'm forcing all of my variables. So I essentially have added 6 new variables, these D ones, which assume a certain value depending on how much I deviate from the goals. And they all need to be greater than or equal to 0. Now I need to decide what's my objective function. And so I can penalize these weights differently. So if I care about goal 1 more than I care about goal 2, then I'm going to penalize any deviation from goal 1 more than I'm going to penalize a deviation from goal 2. So with that, I'm going to take these deviations and I want to minimize essentially the penalized, so P1 D1 plus deviation plus all the others. So P1, this is going to be minus D1 minus. But now I need P2 plus D2 plus, P2 minus D2 minus, P3 plus D3 plus, and then lastly P3 minus D3 minus. And so I have to figure out what these penalties should be depending on how much I care about the different goals. And so we're going to take these and decide, do I care about some of these penalties? If I deviate above some goal, does it really make me unhappy? Or do I care if I deviate above? Or does it only, if I deviate below, is the only thing I care about? And so we assign these penalties, which it could be 0 if we don't care about it. And we want to minimize the penalized deviation. And so here we have goals, and this is a good example because we see all 3 signs. So goal 1, we care about being greater than or equal to 125. So if I'm equal to 125, I'm fine with that. If I'm greater than 125, I'm fine with that as well. So here, if I deviate above, meaning this goes to 126, and D1 plus would have to be 1, that doesn't matter to me. So I would then set D1 plus to be 0, essentially 0 times D1 plus, or I could just take out this whole term. However, I do care if I am under. So if I'm 125, that means I'm not meeting my goal and I still care about it. So I'm going to leave this term in here. Now let's look at the second goal. I have an equality sign. Okay, so just to clarify, if I'm greater than or equal to, then I don't care about the plus term of that goal. So here, greater than or equal to means I didn't care about D1 plus. So we're going to see with equality, that means if I'm equal to 40, I'm happy. But if I'm below 40 or if I'm above 40, I'm not meeting my goal. So that means I care both about D2 plus and D2 minus. So I'm going to keep both of these in my objective function. So lastly here I have a less than or equal to goal. So if I am 55, I'm okay. If I'm 54, or if this evaluates to 54, I'm also happy. So if D3 minus, I don't care much about. So I'm going to change this to 0 times D3 minus. Essentially, I'm eliminating this term. I'm setting its penalty, which I can change the penalty value so that I don't care if I deviate. It's not penalizing me. But if I'm greater than 55, meaning that this evaluates to 56 or higher, that's not good for my goal. And so I'm going to keep this D3 plus into my objective function. So just to reiterate, we have our 3 different goals. We have a greater than or equal to, where we don't care about its plus term. We have an equal to, which we care or penalize the plus and the minus deviations. And here a less than or equal to means we only penalize if we're over. So it's essentially taking the opposite. So here, if I'm greater or equal to, the opposite of that would be less than, and I only care about the less than. So therefore I penalize the minus. And so now I'm going to take this linear programming formulation and plug it into Excel. So all I've done is opened up Professor Sharkey's Excel spreadsheet that he used for class, and I'm going to alter it so it formulates to our problem. So for our problem, we know I only have x1, 2, and 3 variables, so I'm going to delete these columns for these extra variables that I'm not using. I'm going to put back in penalty weights here. And then what are my goals? I have, it's a profit, employment, and investment goal. And what are the parameters for that? So I have 12, 5, 5, 9, 3, 7. And here is 15, 4, 8. And then my deviations, if you look at the constraints here, I had a minus the plus term and a plus the minus term. So like kind of opposite. For all 3 of my constraints here, the goals constraints. So here I have minus the plus term and plus, a positive 1 times the minus term. So these I can keep all the same because I see it's minus then plus, minus then plus. And I have 3 goals, and so therefore I don't need to add in a D4 or plus and D4 minus. So this all matches. I now need to change my right-hand side. So right-hand side, I had 125, 40, and 55. So 125, 40, and 55. Here, for the example he went over in class, there was a constraint that said, I think it had to be less than or equal to 168. We don't have this constraint, so I'm going to delete this row. We do have lower bounds, so these decisions here all have to be greater than or equal to 0. So I'm just going to put a lower bound here of 0 for all of these variables. And then just to reiterate that we're solving for this set of decisions, I'm going to color it differently. So I'm just saying that, it's just a nice visual for me at least, that the solution is going to go here. And I'm solving for these sets of variables, which correspond to the x1 through 3, d1 plus through d3 minus. Here then, as with the linear program, I'm just going to check to make sure the formulas make sense. So here's the sum product of the profit times what my decisions are going to be. And so this carries over, so it looks correct. And then my objective function here is going to be the penalties, which I haven't set yet, I still need to do that, times what my deviation variables are actually going to be. So back when we wrote up the LP formulation, we decided that some of these penalties were 0. And then we could decide, we haven't decided the other variables that or other parameter values, so those p values appropriately. So here, if we go back, we had a greater than or equal to for 125, which meant I didn't care about D1 plus. So for the D1 plus column, I'm going to change this to 0. For the equal, I know I care about deviations above and below, so I'm going to keep those as non-zero. And then here I had a less than or equal to, which meant I don't care about D3 minus. So I'm going to change this here to 0. And so now I have 4 penalties that I haven't set. And the values that I set for this depends on how much I care about the different goals. So if I care about all the goals equally, then they can all have equal weight at 1. If instead I care about goal 1 differently, much more, let's say I care about goal 1 a whole lot more than the other 2, I can put this as a much higher penalty, meaning if I don't meet this goal, then it penalizes me more because I care about the goal more, so any deviations or the deviations in the correct direction hurt me more. And so then you can just solve it. So let's make sure. Here, objective function is M17. I want to minimize. And then I have my decision variables here, which are set correctly as this row. And then here I have the lower bound constraint, so my decisions are greater than or equal to the lower bounds. The next constraint is that the left-hand side, has to equal the right-hand side, which we set it up so they're all equal to. And then here was the constraint that he had before from the example that we don't have. So I'm just going to delete that. I'm going to say simplex, and I'm going to say solve. And so it found a solution. And let's look at the solution here. So I can look at my deviations and say, well, there's no deviation in either direction for goal 1. That means I'm meeting my goal at exactly 125. Same thing with goal 2. I don't have any deviations up or down, so that means I'm meeting exactly at 40. For goal 3, I have a deviation higher, so 6.48. So that means that my essentially left-hand side without deviations is evaluating to 6.48 above 55. So essentially 55 plus this is what my left-hand side is evaluating to. So essentially what it's saying is without deviations, this evaluates to 55 plus 6.48, and that I needed the D3 plus to make it exactly equal to 55. So here I'm above my goal. And so that's how you interpret these different deviations. And then you can change the penalty weights. So if instead I care now more about goal 3, I can change that to 100 and solve the same thing. You have to then look at the relationship between the weights. So here essentially it assumed the same level of deviation. So if I had them all equal, then that means one deviation in D1 minus is equal to one deviation in D2 plus. If instead you cared, so if you said that a deviation of 2 for D1 minus was equal to a deviation of 1 for D2 plus, then you know here that the penalty weight on D1 minus has to be less than the penalty weight on D2 plus. Because if you had 1 and 1 for these two, well then it's worse. D2 plus having a 1 is worse than D2 minus having a 1, because these two scenarios should be equal. So then here you know it's half as bad for D1 minus. So you would just set your penalty weight here to be 0.5. I know that probably wasn't that clear of an explanation, but it's just a way to quantify the different relationships between the deviations. So if you only care about deviations of 2 from D1 minus, and that is equal to a deviation of 1 in D2 plus, then you know that the weight of D1 minus is half what it is for D2 plus. And we didn't talk about the others, so you can just keep them the same. So if this was 5, then this would be 2.5. So I just talked about the relationship of those two. And again, you'd solve and get your solution. So I hope this cleared up some problems that people are having with goal programming. I think I covered a wide range of different things from formulation to Excel and playing with the penalty weights. Let me know if you have any other questions, and good luck with the homework. And again, please give feedback accordingly on the website.